Okay, so we also have an exponential distribution. This is really common in financial data sets. It has this long right-hand tail right here. It is honestly my least favorite distribution to deal with because it causes lots of problems where, as you can imagine, something like the average is really pulled to the right-hand side of the data set, or the right hand by this tail. And so the mean would the average would be somewhere over here. And that's becomes where really the average is sitting where it's not really the weight, the density of the data is over here. And so because the average doesn't describe really the center, well, it decides a center, but not really where the weight, where the bulk of our data is. And that can create some problems in our statistics and really the interpretation from. And so this is often occurs when there's a time between events. Stock market returns follow this exponential type distribution. Okay, and you can see our Python here with this long right-hand tail to help us remember about the exponential distribution. We also have categorical distributions. You don't really think about categories being distributions, but really they're such an important one in data science because we can use these in so many different ways, use them to analyze our data, to classify our data and do different analysis, get really into our data a little bit deeper with these categories. And so understanding the balance or the imbalance that exists in the categories is a really important step in our data analysis and in really understanding the distribution in our categorical data sets. And so the categorical distribution becomes, again, a little bit more important than it would be in classical spreadsheet type of analysis. Here we have a black and white Python here to help us remember what the categoricals. We want to understand the categorical distributions in the data set. We also have many other types of distributions that we deal with. I'll let you read through these. I provided the slide below the video. And so Poisson, beta distribution, gamma distribution, chi-square distribution. It's important to be aware of these. I would say that it's more important to stick to the one of the four major types you're describing. It's easier to communicate. Some people might not really be aware of how these distributions evolve, what affects them. They're less commonly known outside of data science. I would stick to the common ones when you're describing them. If you really feel that is a better fit, a gamma distribution is a better fit, then you can use that, but explain really the gamma distribution with the long right tail that's causing this effect of certain things. The ones that you'll see probably the most common is the student t distribution. And what this is very similar to the normal distribution. It's a little bit more kurtosis in that it's a little bit fatter and it has wider tails. This essentially makes it harder to pass a hypothesis test, which is commonly used when we have data sets where we have a small amount of samples in our data set and still need to perform hypothesis tests. So it's again making it a little bit harder to pass a hypothesis test when we have less data. Really important distribution as well. Not important as the normal, but still very commonly seen.